Unit 4, lesson 3, I believe we're at. You should have had this table out in your notes and tried to fill in as much as you can. A couple of things I want to point out. The idea behind these tables is that we're taking a look at what happens when you get into zero exponents and then negative exponents based on numbers you're familiar with. So if you're filling in your tables, you should have been able to fill in your powers. You could have typed it in your calculator and got 2 to the 4 equals 16, 2 to the 3 equals 8, 2 to the 2 equals 4, 2 to the 1 equals 0, or sorry, 2 to the 1 equals 2, 2 to the 0 equals 1, and so on down the table. And if you want to make a number into a fraction, you should already know, and if you don't, you need to remember this. If I have a whole number of 16, I put 16 over 1, and it's a fraction. If I have 8, 8 over 1 is a fraction, and so on and so forth. If I have a whole number, I put it over 1, and I make it into a fraction. And if we go down our line, you should know that 0.5 is a half. And you should know that 0.25 is a quarter, 25 cents, so it's a quarter. And if we look for patterns, we'll notice we've got 1 in the center, and then we have 2 over 1 and 1 over 2. So a positive 1 is 2 over 1, and a negative 1 for the exponent is 1 over 2. And if I keep looking for patterns, I have 4 over 1 and 1 over 4. A positive 2 is 4, and a negative 2 is 1 over 4. And if I keep going, I've got an 8, and that next one down here should be 1 over 8. A positive 3 is 8, and a negative 3 is 1 over 8. And the last pattern, if I had 16 over 1, the last fraction should be 1 over 16. Positive 4 exponent is 16, and negative 4 exponent is 1 over 16. And if you look at the other tables, the same pattern happens. I have 1 in the middle, and 3 of the exponent is 3 wholes, so that's 3 over 1, and 3 to the exponent negative 1 is 1 over 3. And 3 to the exponent 2 is 9, and 3 to the negative 2 is 1 over 9. And 3 to the 3 is 27, and 3 to the negative 3 is 1 over 27. And so on through the table. And the same thing with the tens. So if we look at patterns, we're going to talk about how that's going to help us know what a zero exponent is and a negative exponent. If we look at our tables, 16 divided by 2 would give me 8, and 8 divided by 2 would give me 4, and 4 divided by 2 would give me 2, and if I keep on with that pattern, then the next one must be a 1. And I can do the same with my 3's. I have base of 3, 81 divided by 3 is 27, 27 divided by 3 is 9, 9 divided by 3 is 3, 3 divided by 3 would be 1. So two things are going on here. We're taking a look at patterns to help us understand a zero exponent, and patterns to help us understand negative exponent. So anything with an exponent of 0 will always equal 1. And the only way I have to explain that is the pattern I just talked about. If you look at the table and you work your way down and divide by the base, every time you hit the exponent of 0, the answer always is 1. So any power with an exponent of 0 will always equal 1. A negative exponent is a little trickier. So we talked about the pattern. Positive 1 exponent was 2, a negative 1 exponent is a half. Positive 2 exponent is 4, negative 2 exponent is a quarter. So a negative exponent is evaluated by flipping the base. So if you have a negative exponent, you can make it positive if you take the reciprocal. That means flip it around. So in the questions we were looking at, we had 2 to the negative 2. And if I flip it around, I end up with 1 over 4, just like the pattern in the table. Or if I had 2 to the negative 3, if I flip it around, I put 1 over, it ends up like the pattern in the table. So the general rule is when you have a negative exponent, to evaluate, to get an answer, you flip the base, and that makes the exponent positive. And once the exponent is positive, you can evaluate. So if I look at some examples, 5 to the negative 3. If I want to get an answer, I've got to put 1 over 5 and make my exponent positive. As soon as I make it a fraction, the exponent is positive. And then I can do 5 to the exponent 3 on my calculator, and I get the answer 1 over 125. So to evaluate a negative exponent, make it into a fraction, and that makes the exponent positive. So 8 to the negative 2 is 1 over 8 to the positive 2. And then you can figure out 8 to the exponent 2 is 64. If you have a negative base, two negatives do not cancel out. The same rule applies. You make it a fraction, you flip it around, and that makes the exponent positive. And then I type it in my calculator, which I left sitting on my desk that I have to go get. So if I have negative 3 to the exponent 5, I'm going to have, oh, I just hit the wrong button. Dang. All right, let's try it again. Negative 3 to the exponent 5 is negative 243. And I just keep on the same. Now be careful, a negative base does not mean you flip, only a negative exponent. So if my base is negative, it just means I have negative 4 times negative 4 times negative 4, 3 times, because the exponent is 3. So my answer would be negative 64. No flipping, no making fractions. Base is negative. I flip my fraction around, so I would have 4 over 1 to the exponent 2. And then we already talked about how you would do 4 squared and 1 squared, which would be 16 over 1, which is just 16. And so if I have a fraction with a negative exponent, I flip my fraction around. Don't forget when you flip something or you make it a fraction to make the exponent positive. So I'd have 3 over 2. And then last but not least, our little zero exponent. Anything to the zero exponent always equals 1, no matter what. All right, so that gives you a look at zero and negative exponents. You need to try some on your own.